Hi there, and welcome to today's class. We'll try to prove that sine x is equal to minus cos x using first principle. Sorry, equal to cos x per se. So for this class, we'll try to prove that y is equal to sine x. What we know is that the value of the x is what? Cos x. How? How is it possible? We'll try to do this using the concept of first principle of differentiation. All right, let's get this done, please. We said very first task here is that so y, I see y, had change in y is equal to I'm seeing sine into this x, add what there, had change in x. So I'm saying to y, add in y, to x, add in x. At this point here, I'll take this y to the other side. I'll have that change in y is equal to what there, sine into x plus change in x minus y. If a plus y comes, it becomes what? A negative y. By the way, but y from the question was what? Sine x. So this means that I'll have change in y to be equal to sine into x plus change in x minus what is y? Y is sine x. I have sine x. At this point now, I'll recall a popular trick function that says that if I have sine, I'll recall that if I from here now, I'll recall a popular trick function that says that if I have sine A minus sine B, this is equal to 2 sine A plus B over 2 cos A minus B over 2. This becomes a concept of trigonometry, right? Sine A minus sine B, that's 2, that should be 2 cos, let's say it's cos 2 cos A, then I have sine here, so it becomes my expression here. So I have this expression here for sine A minus sine B, right? So from here, what do we get from here? Let's get our A and B. What's your A? A is what? X plus change in x. YB represents what? X. I'm comparing, please. So for me, what do you get from here? I'll have that change in y is equal to 2 cos into A plus B. What's A? X plus change in x plus what's your B? X over 2. Next up, sine into A, x plus change in x minus B is x over 2. So I have this. From here, I'll have that change in y is now equal to 2 cos into x plus x, of course, 2x plus change in x over 2. So I have this sine. I have sine into s minus x, of course 0. I'll have change in x left over what there? Over 2. So I have this. Basically, from here now, I'll try to simplify this bracket here. So I should be having change in y to be equal to 2 cos into 2x over 2 plus change in x over 2. If I take this back to LCM concept, I should have this as my answer. So I have sine into change in x over 2. All right, these two cancel out this one here. I'll be having what's left. Change in y to be equal to 2 cos into x plus change in x over 2. I have this sine into change in x over 2. All right. From here, what I get from here? My next task from here obviously is to divide both sides by changing x. So I'll divide both sides by changing x. So if I divide it by changing x, I'll have change in y over change in x is equal to 2 cos into x plus change in x over 2. Next up, sine into change in x over 2. Mind you, all over what there? Change in x. So I have this. At this point now, my aim now is to cancel out these two. Because of that, I'll try to divide numerator and denominator by what there? By 2. So I have change in y over change in x to be equal to numerator first. That's 2 cos into x plus change in x over 2. Next up, sine change in x over 2. Everything here is just my numerator. We said divide numerator by 2 first. So this all over is this one now. All over. What's my denominator? Just in x, I'll have change in x over 2. We said divide numerator by 2, denominator by 2. So I have this. From here, this one will cancel this one. I'll be having change in y over change in x has been equal to cos into x plus change in x over 2 sine change in x over 2. So I have this, right? Basically all over what there? Change in x over 2. So I have this. Now mind you, if I have sine a over a, of course my answer is 1. What does it mean? If I have sine something over that same thing, my answer is 1. So if I have sine something over that same thing, so this 1, 2, 3 are now 1. So I'm saying that, therefore, I'm saying that sine change in x over 2, all over what there? Change in x over 2. This one now is just 1 from this concept. So therefore, we're having change in y over change in x has been equal to what there? Cos into x plus change in x over 2. So this one sine change in x over 2, change in over 2 is now what? Is not just, it's just 1. For me, I'll have change in y over change in x has been equal to cos into x plus change in x over 2. So I have this, right? 1 times anything is that thing. So I have this. We said whenever you divide through by changing x and you are still left with what? Changing x, you take limit of this thing in x to be 0. So I'm saying that the limit of changing x to be 0, it means that anywhere is changing x, I'll put 0. Put 0 here, I'll have that change in y over change in x is equal to what there? Cos into x plus 0 over 2. Basically 0 over 2 is just 0, so have 0 here. So x plus 0 is x, so I'll have that change in y over change in s is equal to what there? Cos x. This is my answer. So this is why if I differentiate sine x, I'll have just cos x. So see you in our next class. If you found this class helpful, do it to like, subscribe to my channel, share to your friends and classmates, very important please, and do it to like the video. You can also reach out by giving us a thanks, right? As you can see the YouTube, you see a download icon, you see download, you see share, you see a thanks there. You can click on the thanks to share us any amount you can afford, right? So thank you and welcome to Excellent Link Academy. Also do well to join our membership program, as you can see in the channel. So just enter my channel, you see join. You can join our membership there to get full lifetime access to tutorial courses there, right? So see you in the next class.